Morning, everybody. I'm very honored to be here and humbling to be following Henrik in my keynote address here. Thank you, Habib, for inviting me to do this. It's quite an honor. I've been down this week at the conference in Baltimore, and we started out at the International Partnering Symposium or Forum with the BNOW group, and then with the AWEA Offshore Wind conference, and now this. And by far, I've been looking forward to this day before all the other ones, because it's very rare that we can actually get together and stop for a while and actually think about where we've been going, where we're trying to get to, and I'm honored right now to try to present a vision for floating turbines, something that I've been thinking about for quite a while. And this is it hasn't been mentioned too much, but this is funded by Matt Simmons, as I understand it. When he died in 2010, the oil spill in the Deepwater Horizon oil spill was still going on, and I had lunch with him about 3 weeks before he died, and he was telling me his stories about how what he thought was going on there. But he had a great passion for the ocean, and he formed the Ocean Energy Institute, which I was a board member that he invited me to be on, among maybe some of you others here. And these are some of the quotes that I found from his website. And he had a passion for developing energy from the ocean, and that's why we're all here today. So I just wanted to recognize that for starters. And then I also want to recognize, Matt mentioned Captain Hieronymus. He was my advisor in college, and he was I think, the pioneer, probably the first person to really put this down on paper and what he had for a vision for floating offshore wind turbines. And he developed these concepts before we even had the bonus wind turbine to look at and know what it looked like. So these were his wind ships, and here's a picture of Captain Hieronymus teaching one of his classes. He was a submarine captain in the U.S. Navy, and he spent just hours and hours on the deck realizing that the wind never stopped when you were out at sea. And he told us that, and he just developed an extreme passion for developing energy systems that could work in the ocean. He died November 2nd, which is almost the exact day that Bob Thresher came into my office and asked me if I would start helping NREL start an offshore wind program, which was kind of ironic for me because I had already learned about a lot of this stuff working with Bill Hieronymus. So I thought that it would be good to maybe go back to the beginning of that program that I was asked to start and recall some of the stuff, just for historic purpose, if not for indulgence. But this was about in 2002, and I had attended a conference in North Carolina where I met a guy from ConocoPhillips who was working on the Hedron. It was a concrete oil and gas platform, a tension leg platform, and I had never even seen anything like that before. And I said we could do this with wind turbines, and so I was drawing some pictures when Thresher came in and said maybe you could do this more of this for the program, because DOE was really interested in getting involved in offshore wind. They had opened up some of their funding opportunities that were now out on the street, and a lot of people were interested because of Horns Rev and because of the other Newstead and some of the projects that were going on in Europe that the U.S. wanted to participate in this. And Cape Wind had just announced, I think, a year before that they wanted to do this project. So DOE came in and said, you know, the Europeans have floating technology commercialized now. I mean, fixed bottom systems commercialized. So we're just going to focus on floating systems. And so in 2003, we said, well, the best way to get into this is let's invite everybody in the world that's involved in floating wind turbine systems, and we'll have a workshop. And we did that. We had a first workshop in 2003 in Washington, and I'm sure I didn't invite everybody, but I invited the people that we heard about and that we knew about, and this is a list of the people that came to that first workshop, including Woody Stoddard and a few others that notable people that you might recognize on there. But as a result of that, DOE did launch some initiatives, and I just want to I started looking back, and some of the stuff that we were looking at back then was very creative, and I think really started us on the right track toward an innovative floating wind turbine industry that was quite different than what you would than the fixed systems. Of course, we became very realistic right after that fixed bottom systems were not entirely fully discovered yet, and the costs needed to come down, and we had to become very practical. But in and through that whole development process, and this was a picture we drew about 11, 12 years ago, we did have this vision for what needed to happen. The evolution of land-based wind turbines, which were at that time much smaller. Turbines had to grow. I think at the time we drew this, the shallow water turbines were just becoming commercial in some of those wind farms. But then we envisioned, of course, a progression as the oil and gas industry did into deeper and deeper water until we needed to float those systems out. And so when I reflect back, this is still pretty much true, and this is still pretty much what we are doing and what we're going to do. The bottom piece there is chopped off, but what's changed is we've actually achieved some of this right now, and so now that we're kind of at this final step. This is the first three stages are commercial technology, and I think floating systems are now what I would call a proven technology, but not a commercial technology, and the cost reduction in this whole pathway is really imperative. That's really the next step. So my vision is these are very high level things, and it really hasn't changed that much. But these systems will evolve from the fixed bottom floating offshore technology, which is now commercial. And I quote Jim Lyons when we first started doing this from GE, who really declared that the floating technologies would be the end game for wind energy. And these are the frontiers in the big, vast areas of wind where we can actually do gigawatt scale projects. Because I think that we can get the costs down for floating systems below where fixed offshore wind is today, and at the same time have lower impacts on because they're further out. I think that there's a lot of work to be done in where these markets might be. I haven't really begun to explore this, so I apologize that the rest of this is probably very U.S.-centric, but it does apply to the rest of the world and other things. And I also think we've also done some work beyond fixed bottom and tethered floating systems, where I think there's a possibility that we can use floating systems to generate fuels and chemicals for transportation that don't even need to be tethered. They actually wind turbines that float as ships in the sea on the high seas. And I don't really want to get into that today, but I don't think that maybe Jim Lyons maybe it isn't the end game. Maybe there's a step beyond that. So cost is the reality. Cost reduction is the reality. There's a lot we can do. Henrik covered a lot of that, but this is the way I see it. Really, there's a least cost fuel that everybody says we're trying to get to. Maybe that's natural gas, but really there's a market price that we need to get to that is really based on that least cost price plus a huge amount of policies and benefits that might always exist that we really need to get to. And we get there by increasing the scale of the systems, by reducing the risk that's involved, and by the technology innovations. And at least from my perspective here, I like to focus on the innovations. I think that's because I work primarily for a research laboratory, and that's where we can make the biggest difference. The industry needs to be in charge of the scale, and I think that we can help them with risk reduction strategies that really relate to some of the deployments that are necessary to show people that the technical risk isn't what we think it is, or what they think it is. I think there's, as Henrik said, there are perceived risks, and then there are real risks, and we need to address both of them. So I just want to talk a little bit about cost. We did some work recently for Doug Bourne over here. Doug is in charge of the regulatory side of the Pacific Ocean for BOEM. And California is the big dog, right? They have a huge amount of deep water. Not that you're not the big dog. I mean, you, on the East Coast, you know, in the Pacific. Okay, yeah, and you know, probably the 8th largest economy in the world if you took California out of the United States and put it by itself. So so they have a huge potential for wind, huge need for energy, and they've got probably the best and most aggressive policies. So we're looking at California as a new market, but offshore wind hasn't been considered in that state, and one of the reasons is that they have the RPS calculator, and they really didn't think that offshore wind, and especially floating offshore wind, was a serious contender to be challenging solar and land-based wind there. So we wanted to educate them and to enlighten them to the new technologies that are coming out right now. And then we looked at so the first step is to get into their RPS calculator and let offshore wind compete head-to-head with these other technologies. And so we did this analysis, and this was with the help of BOEM, a very enlightening exercise. It was really not a big exercise. We did it really quickly this summer, but I hope to expand upon it. We used our geospatial economic tool set and some windographer programs to help us calculate some hourly data, and we developed some just fairly generic, but what I hope are accurate predictions of what turbines might look like in the future, especially in terms of size. And then we applied the Delphos model, which was developed by BVG, and I think Charlie had something to do with that, and some of the assumptions that relate to how technology can be used to reduce the cost of energy. And when we put that all together, we were able to generate these are the technology assumptions for turbines, and we can talk about if we did that right. In fact, the next step here is to vet this whole process publicly in an industry forum, so that we make sure that when California does apply this, that everybody agrees it's a good idea. But we were able to get some very aggressive cost reductions if we go up to the 2030, and I think what looks like to me something that could compete on these markets. This is for floating technologies. And so this is our cost curve, and the symbols represent the different sites that we found in California. These are typical representative sites in California. And so that's very encouraging. And but I want to make a point here that this analysis assumes kind of a strategy for business as usual that we're working on. We based a lot of our economics. In fact, we based all our economics in this new market report that we just published this week. It's really a survey of the entire market, but we looked at some economic trends for what the industry is doing, and we looked at basically what LCOE really is doing based on the market, based on the projects that are reporting costs and reporting technologies out there. And the next few slides I have kind of relate to that. And now this is important because this shows the global pipeline for offshore wind in the entire world. And basically what we're doing here is all we're doing is going out into the literature, and we're looking at all the projects that have reported costs, reported technology, and announced that they are doing things. And we found that the pipeline for offshore wind is about 250 gigawatts. that's a substantial market for an OEM and for people to be looking at. And I attribute the size of this market to the fact that we're now, for the first time, really starting to see costs come down. A lot of people have been concerned that costs haven't been coming down. A lot of the reasons costs haven't been coming down is because the projects have been getting further from shore and they're going into deeper water, and any efforts we've done till now to offset that have been challenged by these other site conditions. But I think right now what we're seeing is that the new suite of offshore for-purpose custom designed wind turbines are just now entering the market. Up until very recently, the turbines going in have been much smaller and began really as land-based turbines that had been marinized. I think you might have even made up that word. My dictionary and my computer doesn't recognize it yet. But marinized turbines are different than I think custom offshore turbines, which I think the Siemens 6 megawatt machine would be a custom machine that was designed for an offshore market. And when we see these turbines being put in, for the first time we're seeing the costs start to come down for fixed bottom machines. So the point I want to make here is that there's an evolution in turbines, and I think we're in the middle of this right now. We started out in the 2000s with land-based turbines that were essentially marinized and brought to the offshore side and installed, and those were the machines that everybody was using. And the costs, they didn't really bring the costs down, but they created the market. In the period we're in right now, and I really did this hoarsely from like 2010 to sometime in the future, we're going to be deploying these, and I think they'll continue to improve, these offshore specific designs that are in the 6 to 8 megawatt class. And these are the things, and I see the industry even moving beyond that to, I think we'll see 10 megawatts, and that's what we put into the calculator. So we've seen that split, that bifurcation of land-based and floating happen, and that's happening now. So my vision for the future really is that we need to see that market certainty that we see for fixed bottom systems come for floating systems, and then we will see another split where we have actual for-purpose floating turbines which will be optimized. And I think that when we see that's when we will see the real price advantage that floating systems can probably offer. And I need probably some, I have some support that would happen. So we need to create market certainty for floating wind energy in order to achieve those optimized systems. And I think some of the platform designers probably know what I'm talking about, because basically every platform is designed for a specific turbine. This is the turbine that has to work on your Pallistar. You can't change the turbine, you can only change the platform, right? And so you can only do so much with the, lowering the cost. So what do we need to do? We need to lower the cost of floating. When we did we haven't published anything on this yet, but my estimation is that floating, as it is right now, we've got a lot of input from different manufacturers who've done this. We're still higher than fixed bottom systems, but we're not that much higher. We're within reach. With the technologies, without an optimized system, I think we can get the costs down just through some of these things we're talking about, at least to the point of where they compete with fixed bottom systems. And I think we can do that. And if we can do that, then we can create at least some kind of a market that would allow the perceptions of technology risk to be demonstrated or mitigated. And I think we do that by demonstration. We put turbines in and we show the people that they work. We can continue to mature the technology and conduct field tests. And we need a really good validation data set that's in the public domain so people can run the codes and the models and the design tools and get that data out there. And then we need to give credibility to the people who are doing these commercial and pre-commercial projects by updating the standards and the regulatory processes so we can get these turbines in, and that they're recognized by a certification process. And both for the fixed bottom and for the floating, we need to continue to develop these other strategies for price benefits and market benefits, because there are some very unique benefits to floating technologies and fixed bottom technologies that aren't being accounted for in the cost of energy calculations. So what if we could change the part that's on top of this? This is our very simple sizing tool model, and we could look at optimized turbines. What would we do? We might, and I don't know that we would do all this, but these are some of the things we were looking at. If you can take, if this pie chart shows my very rough estimate of.
Move your table here. So
oh, sorry. Yeah,
that's fine.
Yeah, you can't see everything. I think we're right there is good.
Okay. We have a floating wind turbine core, dynamic cable here.
See if you can see it for that. So when you look at all the contributions of weight for a floating system, most of it's under the water. Most all of it's under the water, as you know, and there's a part above the water that's the tower and the turbine, and presumably everything below the water is there to hold up the stuff that's above the water. And so making the stuff, the turbine and the tower lighter and lowering the CG is going to inherently drop costs from the entire system, and this is some of the strategies that we need to look at. You don't need to do that for fixed bottom systems, and you wouldn't. It wouldn't be cost effective. And I'm curious to maybe talk to Henrik and others to see how much we can push that envelope. But I have at least some thoughts that we'd like to look at. More composite technologies in the turbine itself and in the tower. And I know Habib has done a lot of work on that already. But also looking at the way the rotors work and the size of the machines, the construction methods all are integrated into the way we design the machines. And we could have a whole seminar on this thing, but this is something that I would like to get to, and it's something that I think that the Department of Energy, as a research contributor to the whole industry, could be doing work in this area, because it's something that industry is probably going to need and isn't working on right now. And as I said, there's no market certainty for floating systems, so the OEMs aren't yet doing this. But they will be soon, and that's my prediction anyway. This is what the floating market does look like. There's a scattering of projects that are either built, these are the blue dots, or planned and in the works. And if some of this materializes and it seems to be expanding annually, we will see a market form for floating turbines. I want to just kind of shift gears a little bit before I wrap up. We are looking at a reclassification of how we look at the resource in the United States, and I think when we first started out, if you see the red line, it's hard to see. This one here. We arbitrarily set a 50 nautical mile boundary, and we said, well, we won't need to go out past 50 nautical miles because that's good enough. We have enough resource inside that. But that was, we weren't thinking strategically, I think. And I think that from a technology standpoint, a better metric would be a depth isobath. And so we were going to change the way we calculate the resource in the United States according to depth rather than distance from shore. Because of course, look at California. There's a lot of inaccessible, unrecoverable resource beyond 1,000 meters that's still within that 50 nautical mile side. But on the East Coast, we've got a lot of less than 1,000 meter depth that's well outside that. And so if we start thinking, well, maybe there's an opportunity there for very large wind farms that are maybe further out, maybe not all the way out to 100 nautical miles, but further out than 50 that might support some sizable floating systems. And we don't really even know what the wind speeds are in places like the South Atlantic Bight, where we know it's calm near the coast in Georgia, but there might be some wind out there, and we haven't really fully figured that out yet. So we want to do that, and maybe talk about, and maybe we can talk about this in the breakout sessions, whether there ought to be a round of wind energy areas that might be outside the rim where the current wind energy areas are, and we can speculate with that with Bohm folks and others here about whether that's going to make sense, because right now the current wind energy areas can support about 19 gigawatts if we fully build them out, but the wind vision says we're going to build 86 gigawatts, and I think that's a lower bound if you want to avert serious climate change problems in the in the world, and the United States is a key contributor to that. So I'm going to skip this, but the cost reduction strategies for floating systems, there's many more besides the turbine. I wanted to mention the turbine. I think we can do a lot with moorings. I think we can do a lot with the way we mass produce, and as Henrik already said in a major way, but work at sea, placing anchors, and the way we do that efficiently and quickly. And in conclusion, I just want to just kind of wrap up and say, I think floating technology is evolving pretty much the way we might have thought it would. It's about where I think the fixed bottom offshore wind was in the 1990s. It's just getting started. We haven't seen the big commercial projects yet. The baseline costs are probably still higher than fixed, but I think with the next few pilot projects, we're going to see those costs come down even further, or come down to a point where we can create a market. We need to create that market. It's a chicken egg thing, as it usually is. We need to avert the perceived technical risk, so that we can mitigate that through innovation and through the supply chain and maturing the infrastructure, which a lot of the fixed bottom infrastructure can be directly used for this technology, and demonstrate this on a pilot scales that show people that this isn't as scary as it might look. And I think even to some of our peers in the industry, this appears scary. And I think if we do that, we're going to see lower impacts on this technology and greater potential for systems. And I think ultimately this floating technology can be a cheaper form of offshore energy than the fixed bottom stuff that's out there right now. So that's my final slide. Thank you.
Thank you.
Yeah, I first of all, I think others in this room can probably address your specific thing, but I think it's not a good precedent to start talking about I see this as kind of us all on the same team, and that we shouldn't start taking sides on on these things. But I understand that there might be a reality where some of the some competition, which is normal for any industry, right? That some competition is starting to arise, which, from my experience in land-based wind, that means that you're being taken seriously, and that's a good thing, because up until I think 1995, no one noticed us and they left us alone, and then all of a sudden, wind turbines were being trashed in the media, and that means that they were threatened by your existence. And I think some of that might be going on now, which that's good news, right?
It's good news, but now it's not good news for your CapEx.
I was basing that on the pre-commercialization of the technology right now. So,
Okay.
So we didn't have. I don't think. Maybe Henrik would disagree where that line gets drawn with commercialization of floating versus fixed. I think that in the 1990s, those were mostly demonstration projects, right? And that's kind of where we are today. Statoil is going out to Scotland, probably with the first multi-turbine demonstration project in Scotland, I think in 2017. And I think we may see some projects follow quickly. PPI, I think, has something going in about the same time, we hope, maybe. Some of the demo projects at DOE. So that's kind of, if those happen, then that's where we are. And I don't, but there is, the first commercial project is not yet far enough in the pipeline that I could say it's going to happen. I think, the Newstead or Hornsreb, it's not there yet. Yeah. It's a good question. I don't think we have a major program. We have a tool that we're implementing in-house that allows us to do updates of our mesoscale analysis. But right now, what we're using for deep ocean and for further out are the NASA MIRA data that are available to anyone. And that's how we were able to make hybrid data sets on the West Coast for hourly projections, combining that with the more proprietary AWS True Power data sets that we obtain from them. And in the future, we're developing the capability to do those internally on our own, but it's basically the same technology as what we've been developing with higher resolution mesoscale models at our disposal.
Obviously, thank you, but for financing, you need more site-specific. I know Habib has done more.
You're talking about site-specific?
Or, a few places on the east and west coast of the Gulf. Obviously, developers need greater certainty. So there's no DOE program down the road?
The validation you're talking about probably is the remote sensing LiDAR systems that are observations that we're getting closer and closer to being able to count on those and to bank those. Right, and I'm sure you're as aware of those as I am. Weight, and I think supply chain also, because I think that I think we want to look at strategies for possibly manufacturing heavy components in closer to where the projects are. And I envision that there may be ways to make a hub or a bed plate where you don't have to go to a big casting place in a foreign country.
Well, thank you for a very inspiring talk.